This is for exam. Problem 1. So what they want us to find how long the time, they want us to find the time after the projectile is launched where it meets the maximum height. So they want us to find the time that the projectile meets the maximum height. So our initial velocity of the projectile is 25 meters per second. And we're at an angle of 36.9 degrees. Ooh, 99 degrees. So we have the degrees, so we can find the x components and the y components of velocity at the angle. So we use v of y is equal to 6.9 cosine of 36.9 degrees, and v, oh no, that's x, that's x, and y is equal to 36.9 sine of 25, what the freak? I'm sorry, my bad. 36.9 degrees, so this is 25 meters per second, my bad, times the angle, so the initial velocity times the angle to find the x and y components. That's where we can find the initial velocity in the x and y direction. So this is equal to, get my calculator. It's equal to, you do 25.0 times, no, cosine of 36.9 equal to 19.99 meters per second. And then initial velocity in the y direction is 25 sine of 0.9, and that gives us 15.01 meters per second. So after we find the initial velocity, we know that at the highest point that the vertical velocity is equal to 0. So at this time, we only have a y velocity. So our equation for time would equal the time. For time, we would use this equation to find the time. We would use the initial velocity of y no, we will use the velocity equation for y, my bad. So velocity of y is equal to the initial velocity of y minus the acceleration times time 1. So we would set that equation equal to 0, we'll set this equation equal to 0, and we would have subtract the initial velocity. Acceleration times time is equal to, well, negative initial velocity of y divided by negative g. G is, in this equation, g is equal to negative 9. G is equal to 9.8. 9.8 because we're going up. 9.8. 8 meters per second squared because we're going up. Because the projectile is launching up, so it's not falling. So the time will equal the initial velocity of y, which is 15.01 meters per second divided by 9.80 meters per second squared, and that would give us a time of 1.533 seconds. So the time that it takes the projectile to reach a maximum height after it was launched from the ground would be 1.53 seconds.